ओके सर, स्लाइड मोड कर लीजिए सर।
Slide.
स्लाइड
1 minute. Slide mode. I think it is visible to all.
मोबाइल आइकन दिख रहा है आपका, ये मोबाइल आइकन को इसको हाइड कर लीजिए। वहां पे होगा ऊपर क्रॉस का, सबसे ऊपर क्रॉस का, सबसे ऊपर कोने में सर, दाएं से। हाँ, क्रॉस
This
वाला,
one.
क्रॉस वाला। नहीं सर,
Okay.
नो, राइट साइड। हाँ, यही।
Okay, okay, na? This is fine?
हाँ सर, ओके।
Okay. Good evening to all, respected all dignitaries, faculty members, member of organizing committee, and my dear student. Myself, Dr. Narendra Kumar. I am working as assistant professor in Department of Livestock Production Management at College of Veterinary and Animal Science, Banda University of Agriculture and Technology, Banda. Today, I will present on topic a very recent topic, that is climate resilient strategies for sustainable livestock production. And first, I will start with the introduction. So, as we know, the livestock production play an important role in ensuring food security and nutritional as well as rural livelihood securities, particularly in the developing countries like Indian conditions. If we see that there are more than 20 million people are dependent, which is solely on the livestock sources for their livelihood securities. And the contribution of the livestock in agriculture GDP, it is around 31%. And solely livestock, its own contribution to national GDP is around 5.5%. So in this way, we can say that this livestock sector is a pivot role for the rural livelihood security. But however, this sector is currently challenged by the climate change. Climate stress like increasing temperature, erratic rainfall, flood, drought, and occurrence of some disease and parasite occurrence. Further, this sector is responsible for, if we see that this sector is responsible for 14.5% anthropogenic global greenhouse gas emission, which is a threat to the climate, which is another threat to the climate. So this lead to the rising concept of the climate resilience livestock production. This will, which will for the adoption of the some adaptive breeding, health, and other management practices that enable to sustain their productivity, profitability, and environmental sustainability. So, if we see the as a whole, what is the impact of climate change on livestock production? There are first we have to understand what is the climate change. Climate change is referred to the long-term changes in the weather, average weather pattern. Average weather pattern is like temperature, rainfall, relative humidity, photoperiods. These are the changes. These environmental variables like these, whatever I've discussed, has a direct and indirect effect on the animal. In the direct effect, on the health, animal growth production, animal production as well as reproduction, negatively effect on these parameter. And in later slide, we have discussed on the what are the direct and what are the indirect effect and how to mitigate these challenges. And in basic indirect challenges like shortage of feed and fodder to the animal, shortage of water availability, there is a occurrence of parasite and vector-borne diseases in animal, and some new occurrence of zoonotic diseases in the animal. So and one thing is that it also affect the quantity as well as quality of the feed. Because if we see that the quality of the feed, there is a more lignin content in the fodder due to the climate change. Due to the climate change, there is a more ASEAN production in the sorghum also. When the weather is a hot and cloudy weather, there is a more production of hydrogen cyanide. That is a toxic material in the sorghum feed, which is given to the animal. So, what are the different sources of the greenhouse gas? Greenhouse gas, like what is the greenhouse gas? This is the basically methane, CO2 and N2O. These are the basically three important gases which are emitted by the animal, and there are the two different sources categorized, that is direct and indirect source. In the direct source we have the enteric methane emission. Basically it is methane emission. And manure management, in the manure there is a nitrogen oxide, N2O. Lot of the N2O is released from this. And the indirect sources, in the indirect sources basically there are the CO2, like CO2 are produced in the livestock farm that are associated with the land use changes, like deforestation, like intensification of the livestock, fossil fuel burning, fertilizer production, feed production, and the use of some processing and transportation of some refrigerated products. This will all generate to the greenhouse gas emission. In the figure number 2, this is the contribution of the greenhouse gas by the species wise. If we see that the cattle and buffalo, these cattle and buffalo are responsible for more than 90% of the total enteric methane emission, and sheep and goat only responsible for 7.7%, and pig is only other animal are less than 1%. And in the figure number 3, it is shown that the 44.1% greenhouse gas is contributed by the methane only. That is enteric fermentation. 13.4% by the N2O, this is nitric oxide, and only 13% by CO2, that is due to feed production. So if we study the effect of heat stress on the various direct and indirect parameter to the animal in detail. So the impact of heat stress on the rumen function. So if there is a heat stress on the animal, there is the more production of there is a increase in the respiration rate, and there is a drooling of saliva. Means drooling of saliva is there, and the animal is the negative diameter intake. Means diameter intake of the animal will decrease, and it will reduce to there is a less production of saliva, which will, as we know, the saliva will act like a buffer in the rumen. So it will ultimately produce to SARA, that is subacute renal acidosis, that is we also known as the decrease in the rumen pH. And second function, it will decrease the rumen fermentation pattern, production of the more acetate and butyric acid, and decreased propionic acid, which resulted into ultimately more methane production. Again, global greenhouse gas production, one of the potent greenhouse gas production. So second important thing, the effect of heat stress on the milk production and the reproduction of the animal, which is very important. If we see when there is a heat stress on the animal, when animal is in stress, there is either it is a cold or heat stress, whatever it may be, there is a increased production of ACTH. ACTH means adrenocorticotropic hormone, which is released from the pituitary gland, and it will act on the adrenal gland. adrenal gland, which will resulted into the production of glucocorticoid hormone and cortisol production. This cortisol production will inhibit the follicular and ovulation pattern that will resulted into the poor fertilization, poor conception rate, early embryonic death, and lower conception. Pregnancy rate will decrease. One thing is another, when there is a heat stress, animal is in negative energy balance, decreased diameter intake, and it will resulted into the less production of gonadotropic releasing hormone, that is GnRH and LH production. When there is a decrease GnRH and LH production, animal heat stress, when the animal heat will not be proper, that is poor heat stress sign. Animal will poor OA quality is there, means ultimately delayed ovulation is there, ultimately poor function of the reproductive performance of the animal. Third important is that is the effect of heat stress on the immune system. When there is a animal on heat stress, again that is adrenocorticotropic releasing hormone is formed, and it will act on the same pattern, means that is hypothalamus, pituitary, and adrenal axis. There is a less production of cytokines, and these cytokines will decrease the innate and adaptive immune response, means it will decrease the cellular activity defense mechanism as well as humoral immune defense system. And it is seen that the more production of cortisol is there, there is a more production of reactive oxygen species, which will resulted into the productive and reproductive performance of the animal will be decreased. So ultimately what we have seen that it will decrease the animal production, reproduction, immune system, and negative indirectly affect to the fodder qualities, fodder quantity, water quality also. And one thing is that it is that this thermal stress on the animal on breeding bull. The breeding bull, we know that the sire is the breeding bull is the half of the herd, that is the testis, where the that spermatogenesis process is taken place in interstitial cell, that is ICH. But due to the more change in the climate pattern, there is the decrease spermatogenesis process. It inhibits the semen volume and concentration. It decrease the sperm concentration, resulting into the poor semen quality and ultimately decrease fertility through the AI. So it is very important to understand the animal is in heat stress. How we know that the animal is in stress or not? Heat stress is not. So there is the three important concept is there in the slide. One is the homeothermic zone, second is the thermoneutral zone, and third is the thermal comfort zone. In the homeothermic zone, where the animal maintain their body temperature, means core body temperature, through various physiological modifications. In thermoneutral zone, it is the within the homeothermic zone where the body temperature, where the BMR is the minimal rate, and animal maintain their body temperature through passive mechanism. Means animal's behavior will not change. Animal behavior will not change. It will passively control the body temperature. And third one is the thermal comfort. Thermal comfort, where the animal BMR is at constant, and constant. It will there is no cold, there is no warm zone. that is 60, and it is basically most of the Indian cattle, it is 65 degree Fahrenheit to 75 degree Fahrenheit to the most of the dairy cattle. That is thermal comfort zone. And before this zone, the animal body is unable to maintain their core body temperature, and it will again go to hypothermia, and when the temperature increase, that is the hyperthermia. That is, both are the stress condition, that is heat stress and cold stress. How we measure this this heat stress? That is the one important measure is the thermal humidity index, that is THI. The THI is the it is the how we measure, that is the formula is there, that is 0.72 dry bulb temperature plus wet bulb temperature plus 40.6. Here the this is the chart for the THI. If we see that the yellow line, this yellow line will decrease, will show the temperature and humidity condition, temperature and humidity with less stress to the animal, that is 72. And THI, when it is 72 to 79, it is mild. When it is 80 to 90, 89, it is moderate. Likewise, when it is more than 98, it is called it is fatal condition. When it is more than 90 to 98, it is the severe condition. So on the basis of thermal humidity index, we know by combining this temperature and humidity, by using the formula, we can know the animal is actually in heat stress or not. So what are the various measures to combat this changing climate scenario for the livestock? So if we summarize this, there are basically 4 important steps we can take. That is the genetic modification. That is the second one is the managemental strategy, nutritional strategy, and disease management. In the genetic modification, there are in the genetic modification, there are basically 3 important strategies. First is the selection of heat tolerant, disease resistance breed, local breed, that is selective breeding. And second one is the identification of some biomarker like single nucleotide polymorphism, that is which having some heat shock protein, just like heat shock protein 70, different type ATP1A1, which provide the thermal resistance and adaptation to the animal. It is also seen that the genes that are responsible for the coat color of the animal and hair length, that will also heat resistance in the cell. And so the identification of these biomarkers and introduction into these biomarkers into commercial head, there are these 3 important steps what we follow in the genetic modification. And in the managemental strategies, we have the housing, proper housing, directions, roof and materials. We are used sprinklers, feeding space, like grazing pattern, changing grazing pattern. Some agroforestry practices are also there. And the nutritional practices like the supplementation of some fat, bypass fat, bypass protein is there. There is a supplementation of some electrolytes, oxidate, the vitamins, minerals, some supply of cool drinking water. That is, and next important strategy is the disease management, in which there is a vaccination, deworming, vector control, isolation, quarantine mechanism is there. So in one by one we will be studying. In the genomic technology, like we have told that the There are the gene discovery, transcript profile, genome-wide transcription studies. What is the gene discovery? This is the process of identification of specific genes and some genetic markers, like we have already discussed, like ATP1A1 and heat shock proteins, to identify this. Transcript profiling means, transcript means that is the DNA to mRNA. That is called transcriptome in response to heat stress to identify these. Genome-wide transcription studies means use of technologies like RNA sequencing to measure the expression of thousands of the genes simultaneously. That is the genome-wide association studies. In this, we have to identify the quantitative trade loci, that is QTL and SNP. These are the SNPs which act as the biomarker in response to the heat stress which is related to the rectal temperature. And the HapMap studies, these are the various haplotypes, specific sets of the genetic variations like SNP, I have told, used and introduction of this gene into the commercial herd. And this will result into the climate resilient livestock production. So that the one important management practices is the grazing management practices. In the grazing management practices, this is the adjusting the grazing time, stocking rate, and intensity of the grazing to make animal to make the health of the soil, to as well as the to prevent the global greenhouse gas emission. In the grazing time, like we maintain in winter season late morning grazing, in summer early morning grazing, or late afternoon grazing during the summer time, we can follow. And second important practices is the rotation of pasture, in which the different pastures, the pasture is divided into number of segments, and animal are rotated one pasture to another and in sequential manner. So it will prevent the overgrazing, and it will prevent also the soil erosion. When the soil is not exposed, there is a less production of CO2 and greenhouse gas emission, and soil erosion will be also less. And third important practice is the silvipasture. In the silvipasture, it is the deliberate introduction of some woody plants into the grazing area, where it provides the microclimate to the animal, and more number of animal can be grazed into this area, and productivity also the productivity also enhanced into these practices. Second one is the nutritional management. In the nutritional management, we have to increase the feeding frequency. Increase the feeding frequency, that is 4 times in a day. Normally in the traditional system, we have practiced 2 times a day, but in the climate change, there is an increased heat stress is there. We'll increase the feeding frequency, that is 4 times a day. So then it will be help to reduce the internal heat load of the animal, maintain consistent dry matter intake, and it will also stabilize the some rumen function. And I have told the morning or late afternoon grazing is there. The whatever the feed you have to offer to the animal, that should have the low fiber content, high fermentable carbohydrate, and it have a high quality protein. Means it have a low degradable protein. Means if it is a high degradable protein, it will again production of heat increment to the animal. So again heat load to the animal. So there is a loss of, one important thing is there is a loss of sodium and potassium. So we have to supplement this sodium and potassium in the ratio of 1.5 to 1.6% dry matter of the feed to the potassium, and 0.5% dry matter to the sodium, to increase the milk production in the heat stress cow. There will be supplementation of some antioxidant is there, like vitamin A, E, selenium, zinc. This will also help to beneficial effect, because in heat stress, when I've already told that there is a more production of the ROS, reactive oxygen species is more. There is a more oxidative stress, cytokine disturb system is there, and damaged cell, and so to overcome this effect, we have to supplement this antioxidant. I have also told that there is a when there is a heat stress in the animal, there is a SARA, there is a production of subacute rumen acidosis is there, where the rumen pH decrease. To combat there, we have to introduce the sodium bicarbonate and magnesium oxide. It is an excellent buffer to the animal. So it is given to 200 gram to 250 gram given to the animal per day, and one and all, that is the ad lib supply of drinking water to the animal. And next important strategy is the how we reduce this greenhouse gas emission by through enteric methane emission. As we know that there is a cattle and buffalo. These are the sole introduction of the more than 90% to the enteric methane emission. And so there are some strategy to reduce this greenhouse gas. First one is the dietary manipulation, and second one is the rumen manipulation. In the dietary manipulation, the introduction of high quality forage. Means high quality forage, that is the introduction of some legumes, green fodder in the and this green fodder should be chopped and mixed into the dry fodder, making into TMR form. Increased concentrate level. In increased concentrate level, there is as we increase the concentrate level, there is a less production of acetate and more production of propionate, and it will again decrease methane production in the rumen. Optimized feeding practices means feeding like TMR and feeding TMR practices to stabilize the rumen function. And introduction of some dietary lipid compound means unsaturated fatty acid. When there is an unsaturated fatty acid given to the animal, there is a less production of the greenhouse gas emission, that is methane. Now, one thing is that urea molasses feeding is there. It will decrease the methane production again, and it will also increase the milk production and simultaneously decrease the methane production by 10%. In the rumen manipulation, there are a lot of the inhibitors like nitrate inhibitors. Nitrate, which will sink the that is the hydrogen sinker, competing with the methane production in the rumen. Ultimately, this will also inhibit the rumen methane production. Some probiotics like Saccharomyces, some Aerobacter, some enzymes like cellulase, hemicellulase are also used as some ionophores like monensin, lasalocid, salinomycin. These are monensin is added 200 milligram per day to the animal, high producing cow. And some secondary plant metabolized cannabinoid like tannin, saponin also introduced. It will decrease the methane production, as well also cause to elimination of protozoa in the rumen, because the protozoa and the methane production bacteria are simultaneously working. That's why it ultimately decrease the methane production. So whatever I've told this in this slide, that will ultimately decrease the enteric methane production, that is the methane production. And I've told that the global warming potential of the methane is more than 25%, more than 25% to that of CO2. So some alternative feed sources we can use to the animal, like insect-based protein, single cell protein, some algal food, some byproducts of the fruit and vegetables to the animal in sustainable way. So insect like housefly, beetles, locust, cockroach, these are all having the high source of protein. These are basically used in the poultry and pig industries in high in very similar manner. And single cell protein, it is derived from the various microorganisms like yeast, bacteria, and fungi. We can use, and we have note down that the lot of the fruits and vegetables, these byproducts are wasted as such in India, but we can efficiently use this byproduct into the animal industry, because it is an excellent source of the dietary fiber, antioxidant, vitamins, minerals. And we know that India is the second largest producer of the fruit and vegetables, and its global market sharing is more than 10%. So in this way, we can use this waste animal, this fruit and vegetable waste into the animal industry. Some azolla is a fern, which is a rich source of the that is protein, having more than 20%, having rich in the minerals, vitamins, and it will increase the milk production, and daily weight gain can be also introduced into the animal. Next important strategy is the sustainable farm-based utilization. In the sustainable, the farm-based, that is the collected into form, into solid or liquid or slurry form. In the solid form, that is used as the biogas production, composting, are directly used as a field, are used as a dung cake like fuel. In the slurry form, they are directly collected into oxidation tanks or oxidation lagoons, where they are nitrified and they are returned to the soil, or they are directly sprayed into the land. Second important is the value addition from the farm waste, like cow dung can be used as a herbal mosquito repellent, and is an excellent source for making panchagabya, where the 5 things are used: dung, urine, milk, ghee, curds, along with banana and coconut and jaggery are used, and it's and it is used as a herbicide. And cow urine, which can be used as a therapy in various disorders like diabetes, skin infection, teeth, kidney, jaundice. It is have some medicinal purpose. And one important is the integration of this livestock with other enterprises, like integration of livestock with fish. In this, we can the byproduct of one enterprises become the input of the other enterprises. We can see that the 5 ton to 10 ton kilogram per hectare per year cow dung is sufficient for the 1 hectare pond for the production of fish. That will easily yield to 5 ton fish production per year without any supplementation, and this will roughly 3 to 4 cow will sufficient for this. And one important thing is the biogas production. In the biogas production, it is as we know that it is a renewable and environmental friendly energy source, and basically it is 60% that is methane, and this methane can be collected and used as a bio CNG production, and it will also replace the household what we use the LPG system in LPG. And the end product of this biogas is the slurry, that is an excellent fertilizer for the field. So in this manner we can efficiently use this livestock waste into sustainable manner, or like this biogas plant, this renewable source which can reduce the methane emission, CO2 emission, because it will act as a reducing reliance on the fossil fuel and the firewood burning. Next is the sustainable farm water waste management. As we have know that there is the indirect effect of the climate change on the water availability and its quality also. So it is important to that is to understand to what are the different water management practices that have to taken place for the changing climate. First one is the efficient water harvesting techniques. Efficient water harvesting techniques like we have using rainwater harvesting, rain top, some surface runoff capture, this using dams, some ponds, groundwater recharging system through trenches, some wells we can make. And second one important thing is the weather forecasting and crop insurance system, in which the like heat waves, rainfall, extreme hurricanes, drought, storms, we have emergency preparedness for the this, and government should provide the financial protection to the farmers against the extreme weather condition. Some use of the some drought resistance, drought tolerant, less water consumption feed fodder like sorghum, millet, legumes like cowpea and pigeon pea. These are vital for the climate change because they need less water, and these are easily drought resistance. And next is the floodplain and drainage system management. In the drainage system management, we have upgraded the drainage system channels of urban and rural areas and reconnecting to the water to the floodplain to store the water on the floodplain area. And smart irrigation practices means some use of some now we use some AI and sensor system data analytics to deliver the precise amount of water to the crop as they needed, like drip irrigation system we can use, and some small scale water reservoirs and its reutilization means capture of the some rainwater or runoff water to store into some ponds or wells, some channels, and recharge its groundwater system and use whatever we needs. Next strategy is the housing system. In the basic principle of the housing system is that we have to minimize the unwanted heat production from the animal and facilitate the heat transport, so to provide the comfortable microclimate to the animal. So in the housing system, the first important the physical modification of the environment. In the physical modification of the environment, what we have to do the provision of shade and the enhancing evaporative heat loss. In the provision of the shade, there should be a shade, but the direction of the orientation of shade should be east and west direction, so to less heat load on the animal. Shelter design should be open type, adequate space is there, no restriction for the length, but height should be minimum 10 to 12 feet is there. There is a cross ventilation, natural ventilation is there. And but the roof, the type of roof should be A type. It should be A type means when the sun's rays on the one side, the shadow of the sun rays should be another side. It will be cooler on the another side. The roof, whatever the material used for the roofing of the animal, that should be have low thermal conductivity, and like it is made of the thatches or asbestos sheet, asphaltic roof materials can be used. And the pitch angle of the roof should be less than it should be less than 45, because if it is more than 45, there is a chances of rainwater coming into the shed to the animal, and it will hamper also the ventilation. There is also a ventilation problem. So one thing is that the whatever you have to make the pitch angle, it should be less than 45 degree. The color of the roof, the outer color of the roof should be white. Whatever the light enter into the whatever the sun ray enter into the that is the roof, it will be mostly reflected if it is white. And it is color inside, means somewhat light that is absorbed, somewhat light enter into the animal set, it is absorbed. So it is a white outside, colored inside. And the shelter of the shelter surrounding of the animal, it should be grassy area, paved area should be grassy. So the reflection of the light to the animal, which will cause the ultimate heat load to the animal, is less. So it should be grassy area. Second important thing is the enhancing evaporative heat loss. In the enhancing evaporative loss, we use the fogger, mister, sprinkler system, some evaporative cooling pads along with fan system to draw the outside air when go into the wet porous pads. We can use this animal. And in buffalo, we have to use the bellowing tank, which provide the most comfortable microclimate to the animal. Next important strategy is the use of information communication technology to address this climate changes issue. As we know that the climate play a crucial role in mitigation and adaptability to the climate change by providing data access, decision making, and resource efficiency. And we have to work along with the farmer, researcher, and extension worker together to mitigate this issue. First important strategy is the K management practice, the climate monitoring and early warning system, like remote sensing satellite sensors, weather stations, to timely alert to the farmer, livestock keeper, and community to reducing climate heat load stress. Second important is next is the climate smart livestock practices. In the climate smart livestock, some mobile applications, some SMS advisory, decision supportation tools are used to address the farmer and livestock keeper to provide this some breeding, housing, managemental practices, and disease practices to the animal, and how to reduce the greenhouse gas emission. We can manage this. Third important is data analytics, be using the AI and big data analysis and mapping system to plan the area specific adaptation and mitigation strategy, like in Bundelkhand region of the UP, that is land drought prone area. Next important strategy is the awareness, capacity building, and knowledge sharing, like e-knowledge sharing platform, extension activity, social media platform, and to strengthen training of the farmer, incentive to the farmer to adopt some climate resilience practices to the animal. Next and not more less is that the principle of disease management. That is the last one adaptation strategy. That is the disease management practices, like in the like scientific disposal of the carcass. Like we have know there are two important burial and burning, and incineration process is there. We have to dispose the carcass scientifically. Routine deworming and vaccination about the various diseases like FMD, HS, BQ, PPR in goat. These are various diseases. Maintain sanitation and hygiene, strict hygiene sanitation in the farm, like collection of solid and liquid waste separately, separate manner, and efficiently utilize these waste into sustainable manner. Quarantine management, when animal come into your farm first time, then will be separate the other your flock for 30 days. Then isolation of sick animal, that is another practices. Periodic health examinations of the animal for the various diseases like TB, JD, brucella, various diseases. Then the capacity building and staff training is there. It is very important to educate the labor and what is the how to produce the clean milk production, how to zoonotic diseases that are transmitted from the animal to human and human to animal. So by utilizing these principles, we can efficiently manage this occurrence of disease. So we can conclude that the climate change is a significant impact on the animal and significant economic losses to the animal also. So to implement these, we have to follow a comprehensive approach that should combine some managemental practices, climate smart practices, resource efficiency use, local breeds, some land management, pasture management practices to reduce and mitigate this greenhouse gas emission, and using the traditional practices along with some modern practices which will support further support this system. So overall we can say that the climate resilient production enhance the adaptability, reduce vulnerability, and ensure the long-term sustainability and livestock-based food production and economics. Thank you. Thank you, sir.
Thank you so much, sir. One minute. Now you are unmuted, everyone. If you have any query, you can ask to Naren, sir. Now we have opened the sessions to everyone. If you have any query, you can ask. Can move forward. Everyone,